We're going to take a look at simplifying radicals when variables are involved. So we still need to simplify radicals, and the radicals need to be like terms. So allow me to simply look at the first example here. And if we take a look at our examples, what we notice is maybe, just maybe, our radicals might be like terms. And in fact, they are. So 5 the root of x plus 3 root x minus 4 root x is going to be 5 plus 3 minus 4. So that would be 4 root x. Now it's important to note here that really we're just doing the operation on or we think of it as an operation on the coefficients, and the radicals stay the same. So let me move on to b, hopefully equally as fast. Now when I take a look, my radicals are actually all like. Now I just want to draw your attention that the middle term, when it says negative, it's actually an implied -1. So 6 cube root of x minus 1 cube root of x plus 8 cube root of x. Well, 6 minus 1 is 5 plus 8. Now that's 13 cube root of x. So far, smooth sailing, I hope. Now, allow me to go on to number C. Ooh, it looks like we might have some challenge up ahead. So C, well, I'm just going to try to simplify each radical. Now, the square root of 4y can be simplified as 2 root y. So really, this is 2 root y minus 4. Now, I'm always trying to be very careful when a radical has a coefficient in front and I simplify it. The root of 9y can be simplified into 3 root y. So I wrote it in a different color, and perhaps I'll show you this one. So I recognize that 9 is a perfect square, so I can decompose my radical in the following way. So it can simplify it as 3 root y. Although I'm not done, I'm getting pretty close. This is 2 root y minus, I'm going to carry out that multiplication of 4 times 3 root y, and that's simply 12 root y. Now I hope that this is okay. So if I take a look at this, and a radical just behaves exactly like a polynomial. Some people might argue it is. And if I'm just carrying out this multiplication, 4 times 3 times the root of y, that's just 12. If we carry out like a polynomial, what we see is that we multiply the coefficients and the variable is along for the ride. Now, what we may have to do is we may have to alter d. D is a little bit nastier. D is actually incredibly nasty when we take a look at it. So a really good strategy here is to look at the prime factorization of the denominator. So maybe I'm going to take this work aside. So 20m squared plus m, I'm going to simplify that. So perhaps I could simplify this as to 4 times 5. Well, I did 4 times 5 because 4 is a perfect square, and that might come in handy. Now I'm going to simplify the polynomial, and I recognize that this has a common factor of m, so I can factor that polynomial 20m squared plus m as 4 times 5 times m plus 1. Now, maybe, just maybe, I'm going to try to simplify 45m plus 1. So I know it's under the radical, and wouldn't it be nice if I found a perfect square that is a factor of that coefficient 45? And sure enough, 9 times 5 times m plus 1. Now, to avoid any confusion, maybe I'm going to rewrite this line and this line using a crazy amount of brackets. So this is really 4 times 5 times m, and the blue expression is 9 times 5 times m, and then m plus 1. So I'm just going to rewrite my radicals in the following way. I'm going to put my perfect squares first. That perfect square is 4, and then it's a factor of 5 times m, and then m plus 1. My second radical can be written as 9 times 5 times m plus 1. Now I'm going to make sure that my radical goes all the way to the end of my expression, so that's good. So allow me to simplify the red expression. The red expression can be simplified as 2 5 times m plus 1. The second expression is 3, and I'm going to take out this 9 as a factor, 3. I'm left with the root of 5, times m plus 1. So very simply, as I get to where I'm going, this is 2 times, now this is a big nasty root. Now wouldn't it be nice if I have like terms? So don't fear, I'm going to multiply those coefficients. 3 times 3 is 9, and I'm left with 5m plus 1. So just like with numbers, we can factor polynomial expressions. And wouldn't you know it, we have common, or we have like radicals. So really, 2, the root of 5m times m plus 1 minus 9, the root of 5m times m minus 1 can be thought of as, let me look at my coefficients, and you can simplify it, and let's add a different word to this really nasty radical. You could just call it a banana. So 2 banana minus 9 banana is like -7. So we just really are doing simple subtraction with those with those coefficients, and that's your final result.